Hello everyone, welcome to another video on shell coding on ARM Assembly Linux 32-bit course presented on YouTube. So in this one we are going to talk about the memory addressing methods which we can use in our ARM assembly program. So there are totally three ways by which we can address the memory or access the memory in our program. So those are named as the offset method, pre-indexed method and the post-indexed method. So all of the three memory addressing methods will be just covered in the subsequent videos, including this one too. So in this one we are going to talk about the offset memory addressing method, what is the offset memory addressing method and how we can identify this type of addressing. If you just remember the slide which we have used in the previous video, then you are familiar with this slide. So what we are doing in this is loading the register R0 with an operand register which is storing actually the memory address with respect to the value of accumulate. So what happens after this instruction is executed, the destination register is loaded with the memory address plus the accumulate value. So it dynamically updates the value of operand with respect to the accumulate, and that updated memory address is used to load the data into R0. So this is the only usages of the accumulate in our memory operations. So the way we access the memory makes it different. So this type of addressing the memory is known as offset memory address method, because we are loading the data destination into the destination register via the help of dynamically updated memory address, and we are not updating this operand register too. So what I have done in this slide is just created a sample program, sample layout of a memory address to just showcase you to let you just understand clearly, more simply, where I have declared some memory addresses with respect to the values stored in them, like AA, BB, CC, DD until the GG. So what happens after this instruction is executed, which is actually the offset memory addressing. So before explaining about the instruction result, I need you to just identify the memory addressing method of offset memory addressing method is by, you can just identify offset memory addressing by the data stored inside these square braces. So the any kind of load instruction or the store instruction or any memory operation which is being conducted in your program, if it is stored inside these square braces within accumulate, then you can just simply identify what type of memory addressing we are using in it. So it is actually offset memory addressing. So after executing this particular instruction, what we are instructing to the computer is to load register R1 with the dynamically updated memory address of the R0 plus 12. So what is the value at R0? It is 10100. If we add 10100 with a 12, it will become 1010C in hexadecimal actually. So the data stored at this memory address is DDDD. So the register R1 will store value DDDD into the R1. Also the memory address stored in the operand register is also not updated. So in the upcoming two memory addressing method video, you just only need to focus on the operand 1 register, because everything lies in the updation or update in this value. Three of them have some significance, have some difference with respect to the memory address of the operand register. So make sure you just pay close attention to this value in the upcoming two videos as well. So in this one, it is clearly mentioned the memory address at the operand 1 doesn't get updated or changed. Also, the data is loaded from that updated memory address as well. So this memory addressing method might help in a lot of situations where you want to just directly access any value, like you want to access the data from an array. Suppose you have a array of index 10 and you want to access the index 5 value. So you can load a register by specifying the start address of the array at R0 and accessing the value with an accumulate of 12. Actually not 12, it will be around 24. Yes, R0 plus 24 will be the fifth index of the array. So the register R1 will be loaded with the fifth index of the array. So there are many examples, there are many ways you can use this type of memory addressing. the scope is not limited. But what we are going to do now is to create a simple program where I will showcase you how the things actually work inside a program via showcasing you inside the debugger session. So let's move to our computer screen and I will showcase you how it actually works. So what I have done is simply created a file which you will get in the description for download purposes, so that you can just debug this program on your own machine. So what I am doing in this program piece of code is using the offset memory addressing method to copy the string at the variable 1 into the variable 2. So what we are doing is loading some registers with the memory address of the variables, which is loading the R0 with variable 1, loading R1 with variable 2, and loading R5 because we are going to use accumulate as a register. What we want to do is to copy a string of variable 1 to variable 2, and to achieve that all that code which is responsible for doing that resides in this section, where we are loading a byte from R0 plus R5 and storing it into R2, comparing the R2 with 00, because we know by using the S keys the string is null terminated, and to identify when a string is empty or a string is ended, we can easily say that whenever a 0 is encountered, we can easily say a string is terminated, string is finished. So we are using 00 for identifying that. If that is equal to 0, we are gracefully exiting the process, because we know we have just copied everything from variable 1 to variable 2. And in the next instruction, what we are saying, store the value at R2, which is the exact byte value of the variable 1, store that into the variable 2 memory address with the exact same value of the accumulate, and increment the accumulate. We can also update the memory address by 1. So we are not doing that because there are memory addressing techniques which do it automatically. We have not to do that, which you will get to know in the next video, in the upcoming 2 videos. So for debugging, we are using the almighty debugger, GDB multi-arch, and the keymove arm utility to create a debugger server. After pressing enter in the keymove arm, a debugger server is created, and we will access that via the GDB multi-arch using the command target remote localhost 1234. After pressing enter, we have entered the debugger session. What we can see in these 2 instructions is exactly the loading of the memory address into the R0 and R1. If I show you the memory address of var1 and var2, let me show you. It is 1008C and 1009C. After executing these 2 instructions, the exact value, these 2 values will be stored in R0 and R1 respectively. So let me just show you. So we can see the 1008C and 9C are stored into the R0 and R1 register. It is the memory address of variable 1, and this one is of variable 2. Storing R5 with 0 for the accumulate, loading a byte from R0 plus R5 into the R0 register. If I just show you the hexadecimal byte at variable 1, it is 41. So after stepping this instruction ahead, what thus R2 will store is the 0x41, because we are loading a byte from the memory address of R0, and R0 is 10008C. As we can see, 0x41 is loaded into the R2 register, and next we know that we are comparing the value with 0, so that we can just identify when a string is terminated or ended. So it is not a null byte, so a string will not be terminated. Now we are storing the byte into the string into the memory address of variable 2 with the exact value of R5 or the accumulate. If you just see the string at variable 2, it is 0. But after stepping 1 instruction ahead, the string at variable 2 will be A. Don't focus on this thing because this might seem gibberish, this might seem not intended what we want to do, but after the operation is successfully executed, these all gibberish will be just removed automatically. Let me just set up a breakpoint at the memory address 10078. So what we are doing is just skipping the loop and going on to the breakpoint, setting up a breakpoint before a program is terminated or gracefully exited. So if we just view the string at variable 1 and variable 2, you can easily see we have successfully copied the string from variable 1 to the variable 2, and what we want to see is the memory address of R0 and R1. Those are not updated. We can see that these are all not updated. So this was all the things about the offset memory addressing. We know that the memory address is not updated, but the operation is done successfully. So that's all for the video about the offset memory addressing. If you have any question related to this video, you can just simply ask in the comment section. You can download the code and PDF slides from the description below, and from there, from that slide, you can just locate me on my Twitter and GitHub handles as well. That's all for this one. Meet you in the next one.